Hi again, my name is Sami and I'll be covering some pre-calc or math 12 questions. The questions will be a trig question, then graphing a reciprocal function, and the last one will be function notation. So here's the first one: evaluate cotangent negative 5 pi over 6 over sine 17 pi over 3. In this question, you have to do a few things. For some of you who don't like working with radians, convert this to degrees. So, to convert angles to degrees, you take the negative 5 pi over 6 and multiply it by 180 over pi. So the pi's would cancel, and that will give you negative 150. And then take also the 17 pi over 3, multiply it by 180 over pi. Pi's would cancel. That's 3 goes into itself, 1 goes into 60 times. And then if you multiply that, you get 1020. So you have to draw these two angles to be able to answer this. So the first angle here is the negative 150. So 0, 90, pi, 180, 270, all the way around is 360. So negative 150, you're going in this direction here. So negative 150, it's around here. Bring up a vertical now. If this is negative 150 and negative, you go clockwise when you're measuring angles in negative when you measure angles with negative sign. So you need to find out what the reference angle here is, and it's 30 degrees. And since that's 30 and that's 90, then this is 60 degrees. And this is the special angle triangle where the opposite to 30 is 1 and the opposite to 60 is √3. But both of them will be negative. The reason is the x-axis here is negative and the y-axis here is negative. Now, let's graph also the 1020. So 1020, basically, if you go one round, is 360, another round is 720. 1020 minus 720 is 300, so you have to go 300 more. So that will put you right here, and that's where the angle is. Bring a vertical. So this is 1020. Again, 0, 360, 90, 180, 270. So I went 720 and then I went 300 more. So from here to there is 300, then I have a reference angle here of 60 degrees. And if that's 60, then this is 30. This is 30 right here. Opposite to 60 is √3 from the special angle triangles, and it's got to be negative because the y-axis here is negative. The hypotenuse is 2, and this is 1 because it's positive since the x-axis here is positive. Forget to write the 2 here for this triangle. Now, you could start doing this. So what you have cotangent, and cotangent is the reciprocal of tan. So if tan theta is opposite over adjacent, then the cotangent would be adjacent over opposite. So if you're looking at this triangle here, adjacent over opposite, so it's negative √3 over negative 1, which gives me, so I'll just write it out, negative √3 over negative 1. And for the sine of 17 pi over 3 or 1020 is opposite over hypotenuse, so that's negative √3 over 2. Now this will become negative √3 divided by negative 1, just √3. And since this is division, you change it to multiplication and you flip the divisor. And now you could reduce √3 with √3 right here. So you're left with negative 1 on the bottom. 2 divided by negative 1 is negative 2. And that's the answer for this question. We'll move on to the second question. So here's the question with the graphing reciprocal functions. So when you're graphing reciprocal functions, what you need to do is, first of all, figure out the vertical asymptote. So vertical asymptote. And the vertical asymptote is always the x value that makes the bottom 0. Okay, so x minus 1 here. So the value that makes this bottom 0 is to make x equal 1. So that's where your vertical asymptote is. And so what I'm going to do, I'm going to go ahead and draw my asymptote at 1. And always label your asymptote. So x equals 1 is your asymptote. Now the horizontal asymptote. And the horizontal asymptote, when you're graphing reciprocal function, you have 3 conditions. Or maybe, yeah, let's say 3 conditions. So if the degree on top is less than the degree on the bottom, which is the case here, then y equals 0 is your horizontal asymptote. If the degree on top is greater than the degree on the bottom, then you have no you have no horizontal asymptote. And if the degrees are the same, then you look at the coefficients of the highest degree on top and the highest degree on the bottom, and that will be your asymptote. But for in this case here, the degree on top is less than the degree on the bottom, and therefore y equals 0 is the horizontal asymptote. So it's basically, it's your x-axis. That's what y equals 0 is. Now, if you want to graph this, you could do a little bit of table of values to see what's going on with the graph. And when you're doing the table of values, what you want to do, you want to see what happens when you move away from that vertical asymptote and you go left, to negative infinity. So if you want to do that, then maybe just sub in negative 10 to find the behavior, what the behavior is as you go further to negative infinity. And if you want to find out what the behavior is of the graph when you move to positive infinity, so just use a big number like 10. And also you need to find out what's happening when you're getting close to the asymptote from the left side and from the right side. So if you want to find out what's happening from the left side, you could use 0.9 because that's very close to the vertical asymptote, x equals 1. And also use 1.1 as the it's on the right side of the vertical asymptote, then it'll tell you what the behavior is as you get closer to the asymptote from the right side. So these are your numbers that are of importance. Now, then you could just take your calculator and calculate all this stuff. So I'm just going to do that. So when I did the calculations, these are the numbers that I've gotten. So it doesn't mean you have to plot these number for number, like 0.01 is very minute. But what it's telling you here, it's telling you as you move further this way, what's happening, you're getting close to the x-axis from the bottom. Because if, negative 10 gives you negative 0.01, so you're getting close to the x-axis from the bottom. And also 10 also give you negative 0.01, so also you're getting close to the x-axis from the bottom here as well. Now, how about 0.9? 0.9 is on this side, and it's giving you negative 100. So your graph is shooting down as you get close to the vertical asymptote from the left side. Also, if you're getting close to the asymptote from the right side, 1.1 gave you negative 100. So also your graph is shooting down also on this side as well. And therefore now it's simple, you just know that's what's happening to the graph right here. Also, what you could do to this graph is find the y-intercept. You wouldn't have an x-intercept, obviously, because as you see, the graph is all below. So the y-intercept is just do f of 0, sub in 0 for the x to find the y-intercept. So negative 1 over 0 minus 1 squared. And that will end up giving you negative 1. So if you want a more accuracy, you're going through this point right here, and then just go ahead and wing it. And this is how this graph looks like. Next question. So the third question is function notation. So determine g of f of x. So what does that mean? that means you take the f of x, which is the root x minus 2, put it in for the x and the g of x. That's what it means. So g of f of x is basically the same as g of root x minus 2, which is basically instead of x now in the g of x, the x becomes root x minus 2. So therefore, this you take root x minus 2, and then you square it plus 1. And when you square a square root, just know always squaring a square root, it just cancels the square root. So you end up with x minus 2 plus 1, which gives you x minus 1. Explain why the domain is restricted. So let's find out what the domain is first. The domain, you have to work from here. So you know the domain of any radical function is you cannot square root a negative number. So whatever you take in the square root of cannot be negative. So you have to say x minus 2, it has to be always greater than or equal to 0. And therefore, x has to be greater than or equal to 2. As far as g of x, this is a parabola. There's no restriction on the domain of a parabola. So this is your domain, and explaining why, because you cannot square root a negative. So x minus 2 always have to be 0 or positive number. And that's your answer right there. Here is a log question. So they want you to solve. And here, solving means you're solving for a, the base. So to be able to do this, you have to combine these two logs on the left side first. So we know with the log rules, if we have a number in front of the log, we could just put it on top of the 3 there, and there's the 3 to the power of, hold on a second here, I'm just gonna. So basically what I need to do, just go log base a, and this becomes 3 squared plus log base a 4 equals 2. Now this becomes log base a 9 plus log base a 4, which equals 2. Now, you know, when you have two logs added, you could write them as one log, and then just multiply the 9 and 4 equals 2. Log base a 36 equals 2. And now we go back to the log base a x equals b is the same as x equals a to the b. So we could change this to exponential form. So we know a squared should equal 36. And therefore, if you square root both sides, you're going to get a equals -6 or +6. But we have to reject the -6 because a has to be greater than 0. So just remember the base could never be negative, and it cannot be 0 either. And also you cannot log 0 and you cannot log a negative number. So this is your answer. 6 is your final answer. So here's the trig question. Secant theta plus 2 equals 0. Find theta over the interval 0 to 2 pi. So that means 0, pi, 2 pi, pi over 2, 3 pi over 2. You have to find your angle in this range right here, or this domain. So first thing, let's solve for secant theta first. So secant theta would equal -2 by moving the 2 to the other side. Now, a lot of us don't like to work with secant. So the secant is the reciprocal of cos. So you could go 1 over cos equals -2, or take a shortcut and say cos x, if secant theta equals -2, then cos theta must equal -1/2, the reciprocal. And now the cos is negative. You go here, and all students take calculus. So the cos is negative must be in this quadrant and this quadrant. So you're going to have two angles that have a cos of -1/2 between 0 and 2 pi. Now, after that, you go look at your triangle right here. This is a special angle triangle. Which angle has a cos of 1/2? Is it the 30? No, the 30 has a cos of √3/2. Then it's the 60, because cos 60 adjacent over hypotenuse is 1/2. So definitely 60 degrees. So your reference angle is 60 degrees. And 60 degrees in radians is pi/3. That's what it is. So what you do, you come here and you go, okay, my reference angle right here is pi/3, and also here is pi/3. But that's not the angle that you're looking for. The angles you're looking for is going from 0 all the way to here and 0 all the way to there. So theta 1, the first one, is you go all the way to pi and take away that pi/3. And theta 2 equals all the way to pi and add pi/3, which equals 1 pi is the same as 3/3, because 3/3 is 1 pi. So you could just to do a common denominator, make this 3/3. Now 3 minus 1 is 2 pi/3. And 3 plus 1 is 4 pi/3. And these are your two answers for this question. Here's a quick question. State the amplitude of f of x equals -2 sine x minus pi minus 1. So always remember, when you're doing the amplitude, the common mistake that students do is they look at this right here and they think that all of this is the amplitude. No, it's not. The amplitude equals 2. The negative just represents a reflection over the x-axis. That's what it represents. So basically your maximums becomes minimums and your minimums become maximums. Minus pi here, that's shifting pi to the right. Minus 1 here is shifting down 1. But the amplitude, the common mistake that we see students make all the time, they get a question like this, is worth 2 marks and they choose -2 and they lose that mark. It's 2. So always the amplitude is positive, never negative. Okay. So here is one that says determine the exact value of cos 15. Unfortunately, this one, you cannot just go and put it in your calculator because that will give you a decimal and that's not exact. So what do we do if they want the exact value and it's cos 15? I know this is not a special angle and you cannot go to the unit circle and all of that. So what you need to do, you have to think of an alternative to 15. So 15 could be expressed as 60 minus 45 gives you 15, and definitely the 60 is a special angle and the 45 is a special angle. So now once you do that, you have to remember your addition identity, the adding and subtracting identities for sine and cos. So the cos subtraction identity, it says cos 60 minus 45 will give you cos 60 cos 45 plus sine 60 sine 45. So don't worry, these identities will be given to you on the exam. You could just look at it and know how to write it out. But try to remember that sheet that they give you for the rules, because the only way you're gonna catch up with the question is to know your identity sheet. Then you see something like this and you say, okay, I could do that now. Also, when you prove in identities, you need to know some of your identities by heart, like sine squared plus cos squared equals 1. You don't want to be looking back at that, and also know how to manipulate the sine squared plus cos squared equals 1 in your head. You don't have to write it out. So if sine squared plus cos squared equals 1, then if you move the cos squared to the other side, it becomes sine squared equals 1 minus cos squared, and cos squared will be 1 minus sine squared. Remember all your reciprocal identities, like you shouldn't be looking up secant equals 1 over cos and cosecant equals 1 over sine. Shouldn't even be looking at cotangent equals 1 over tan. And also you have to remember tan equals sine over cos and cotangents equal cos over sine. These, try to remember them. If you look in those up, then you know, identities would float nicely for you. You'll always, there's no connection, when you see a question, you're not connecting. But if you know some of the identities, as soon as you see a question, then something clicks usually and say, oh, okay, this question here, that identity would work for it perfectly. Of course, I don't expect you to remember the tan addition identity and cos 2 theta. Maybe it's a little bit hard to remember, and tan 2 theta, but sine 2 theta also 2 sine theta cos theta. Remember that. It will help you it will help you compute things a bit faster. So there we go. So we wrote, going back to this question, we wrote this out this way now, just straight plugging in cos 60. So cos 60 is adjacent over hypotenuse, so that's 1/2 times cos 45, that's 1/√2, plus sine 60 is √3/2, and sine 45 is just 1/√2. Now this will give me 1/2√2 plus √3/2√2. Since the common denominator is the same, I'm just gonna write it once and write this as 1 plus √3. This is your answer, but it's always a good idea to go and rationalize the denominator. So to rationalize the denominator, multiply by √2 on top and √2 on the bottom. So you multiply the top by √2 and the bottom by √2. A lot of you think rationalizing the denominator, you have to multiply by everything on the bottom. If you do that, you just have to reduce further. But honestly, you only multiply by the root. Okay, so you only multiply by √2. However, if the bottom was 1 plus √3, then you have to multiply both sides by the conjugate, which is 1 minus √3. 1 minus √3, if that's the case, because that's a binomial. But when you have a monomial like this, and you're rationalizing the denominator, all you need to do is just multiply by √2. You don't have to multiply by 2√2. It makes your life a lot easier. It's faster. So √2 times 1. So here you just distributing. You get √2 plus √2 times √3 is √6 all over. √2 times √2 is square root of 4, which is 2, and 2 times 2 is 4. So you have √2 plus √6 over 4, and that's the answer for this one. So here's another question with the function notation. The first thing they say, determine h of x. So h of x is f of x minus g of x. So basically what you want to do here, you want to go, okay, h of x equals f of x, which is x squared plus 5x plus 6, minus g of x, which is x plus 3, which gives you x squared plus 5x plus 6 minus x minus 3. So that's x squared plus 4x plus 3. And that's the answer for A. B, sketch. So to sketch h of x equals x squared plus 4x plus 3. The best way to sketch this, since it's factorable, you factor it, you get x plus 1 and x plus 3 as your factors. Therefore, your zeros or your x-intercepts, if you set it to 0, x equals -1 and -3. So therefore, I know my x-intercepts are right here and right there. And I could find the vertex. I could find the vertex by just doing f of -2. Why f of -2? Because the vertex is always right in between the two zeros or the two x-intercepts, or I mean the axis of symmetry, that's what it should be. So if you want to know where your vertex is, then you sub in -2, the middle between the two zeros, into the equation, which is -2 plus 1 and -2 plus 3. So I'm subbing it in right here. That gives me -1 times 1, which gives me -1. So the vertex is at -2 and -1. So at -2 and -1 will be right here. And then since A is 1 for this parabola, the A value is 1, you know, parabolas, they go out 1, up 1, and then out 1, up 1, 2, 3. So there's your other point if you wish. And then you reflect that into the axis of symmetry if you wish. So that's 1, 2 away from the asymptote. So you go 1, 2 away and you have your other point. You could also do table of values where you sub in a few values, you know, on the right side of the vertex, like x equals -1, x equals 0, 1. Find out what the y value is and then just reflect everything in the asymptote. So there's so many ways to graph parabolas, but this parabola looks exactly like this. And that's it for today. This is good enough. I'll continue with covering the final exam for Math 12. And yes, remember to subscribe if you like my videos, comment and like, and share with others so others could benefit as well. Thank you for watching again. Bye-bye. Till next time.